Alright, hello there all. Okay, today is 8.5 day 2. So yesterday we talked about expanding or expansion, right? Say expanding logarithmic functions. And we said we had three main rules. Alright, if it's multiply, we add log base b of u plus log base b of v. If it was division, log base b of u divided by bv, we would subtract, so that'd be log base b of u minus log base b of v. And then we had our other one where if we had a power, that power would come out in front and my constant would stay put. Alright, so those are the three rules. Now, so yesterday we expanded. Today we're focused on condensing. Alright, so yesterday we took here and went here. Today we're taking this stuff on the right and moving to the left. So we're using the same rules, we're just going the opposite direction. And with condensing, what we do is that we write our log or natural log first. Right, log or natural log first. Okay, or once I should say. And then we combine our terms. And then we combine our terms. So, let's take a look at this. So, number one, I have log base, I keep forgetting my G. Log base 5 of 7 minus log base 5 of x. Alright, so we have subtraction, so we know that's division. So I have log base 5 of 7 over x. Alright, so we're just going the opposite direction today. Okay, number 2. 2 times log of base 10 of x plus log base 10 of 5. Remember, it's base 10, we don't write it. Well, first, I'm going to rewrite this as log base 10 of x squared. Alright, so rule number 3 here, where we pull the exponent in front. So now we're putting it back in the problem, log base 10 of 5. Because it's addition, I have log base 10 of 5 times x squared. And I write the 5 first because it's just, we have our constant first. It makes it nice. Instead of x squared times 5. No, we say 5x squared. Alright, let's look at another one. Let's keep rolling here. 3 times the natural log of x plus 5 times the natural log of y. Well, first we have the natural log of x to the third plus the natural log of y to the fifth. Because it's addition, we have the natural log of x to the third times y to the fifth. Not so bad. Alright. Let's do another one. Natural log of 20 plus 2 times the natural log of 1/2 plus the natural log of x. Okay, well, this one I'm going to leave alone, natural log of 20, plus the natural log of 1/2 squared plus the natural log of x. So I have the natural log of 20 times. Well, 1/2 squared is 1/4. Another addition, so times x. 1/4 of 20 is 5, the natural log of 5x. Alright, let's do a tricky one. Alright, we talked about this one on the board briefly before second period left. First period we didn't get to it, but we're getting to it now. Log base 3 of x minus 2 log base 3 of y. So, now remember, where did this 1 come from? Right, in order to condense that, we have log base 3 of 3, right? Because all these are base 3, and we had one of these situations. So that's where the 1 came from. Then we have plus log base 3 of x minus log base 3 of y squared. So I rewrote that one here. Here we have multiplication. So I have log base 3 of 3 times x. So that's why it's important to change this here. because that 3 plays an important role in our entire problem. And then over here I have minus. So minus implies divided by y squared. Alright, so that's the tricky one. Alright, good stuff. So that's condensing. Now you're comfortable expanding and condensing. So now let's look at another rule we have. And we call it the change of base formula. Alright, and this is the one that helps us solve logarithmic functions or equations. So let's say we have log base b of u. Now, if we had constants in for these variables, alright, so if I gave b, u, assigned them a value, we could solve by doing log base 10 of u divided by log base 10 of b. Alright, so when you type that in your calculator, let's say we had, so if you're using your calculator, we have log base 4 of 7. So in our calculator, we would go log base 10 of 7, and your calculator automatically reads the log, over log of 4. Okay, again, base 10 is assumed. So in your calculator, we could go log of 7, close parentheses, divided by log of 4. So now we're getting to a point where we're not only working with logs, but we can evaluate them also. And we get 1.404, let's say. So this would be approximately 1.404. Alright, so that's how you use your calculator. So I'm assuming we know what's up with the calculator in solving these next few problems. Alright, so let's start. Let's say the directions are going to say solve for x. So I have log base 4 of 7, let's start with something we're familiar with, equals log base 4 of 4 raised to the x. Now, to start with this example, I kept it simple. Notice we have log base 4, log base 4. Alright, that's not always going to occur, but for now it is. So here we're good. We can't do anything over here. Here we know that equals 1. So I'm actually left with log base 4 of 7 equals x. So now I have my variable equals something. And I know how to solve this because we just talked about it up above. In my calculator, I would go log of 7 divided by log of 4. And we know that gave me 1.404. And approximate. It went on. So that's what I would put in for x to make those equal. Alright, so now we're starting to get to a point where we can evaluate for exponents. So let's try another one. Let's go 6 equals 2 raised to the 3x. Now, in the past, we never knew how to solve when a variable is in the exponent, but now we can. Think about this. I want to get the x all alone. So how do I get rid of a base 2? Well, we're going to use this idea here, the inverse of how it equals 1. So the inverse of exponents of bases is actually logs. So because I want to get rid of the 2, I'm going to log base 2 each side. Right? Just like if we were solving an equation and I would multiply 2 by both sides, in order to get rid of that base, I'm going to log base 2 each side. So I have log base 2 of 6 equals, well now I've created this situation, so I'm left with 3x. Alright, and then to get x by itself, I would just divide by 3. But you kind of have to evaluate this first. So I have log of 6 divided by log of 2. So in my calculator, I have log of 6 divided by log of 2, which gives me 2.584, yada, yada, yada. And then we're going to, so we have 2.584, and we're going to divide that by 3 to get x alone. So in your calculator here, divide our answer by 3, and I get 0.862. So x is 0.862. Alright, so not so bad. So now we know how to solve for exponents, but there's a few other things that can happen. So let's try a few more. Let's go 7 equals 3 to the x plus 2. So first we need to get this term all by itself. So I'm going to subtract 2 from each side. So 5 equals 3x. Now again, pay attention to what you want to eliminate. To get the x alone, we need to eliminate a base 3. So I'm going to log base 3 each side. Log base 3 of 5 equals log base 3 of x. 3x, sorry. 3 raised to the x. So now this is gone, and I'm left with log base 3 of 5 equals x. So in your calculator, we go log of 5 divided by log of 3. And we should be comfortable with our calculator now. That gives you 1.465. Alright? Pretty cinchy. Last one. 16 equals 2 raised to the x plus 3. Now, you could log base 2 each side, but there's a little shortcut here if you recognize it. We have a base 2, so can I write 16 as a base of 2? Sure can. 2 to the 4th. So now, if you recognize these two are equal at the same bases, therefore my exponents must be equal. 4 equals x plus 3. Subtract 3, so x is 1. Alright, so basically what logs do is help us accomplish this here. But when we don't have such pretty numbers, we can use this general form, okay, log of 3, to eliminate that, find the inverse, and then use the calculator to calculate the inverse. So that's what allows us to solve for x. Alright, so it's this idea, just with not so pretty numbers. And if you would log base 2 each side here, you would get the same result. Alright, so that's it. See you in the morning.